we good?
Yep.
Alright, well my name is Ali O'Brien, and this is my project partner, Nikita Pressler, and we did the calculus in fruit. Now, how did we come to this concept? Because what correlation does calculus and fruit have? Well, this is how our thought process went. We're like, in the spring, a strawberry starts out as just a sprout, and then by summer it changes and transforms into a juicy strawberry. And we're like, calculus is the mathematics of change. So that's kind of how we came to this idea. Now, throughout this project, Nikita and I developed a sort of motto, and before we got started, we wanted to share that with you. So, knowledge is knowing that a tomato is a fruit, and wisdom is knowing not to put it in a fruit salad. Okay, so throughout this presentation, we're going to hit on 4 calculus concepts, the first 2 being volume by disk method, volume by rotation, and then our arc length and area under the curve, and these concepts will be applied to various fruits.
So for our first concept, we did the volume by disk method, and the fruit of choice for this was a grapefruit because it's a nice spherical shape. So the first step was to cut the grapefruit into equal slices. We happened to do 10 slices of 1 centimeter each. After this, we measured each of the slices diameter and then divide by 2 to get the radius. Using the radius, we were able to calculate the volume of each of our cylindrical slices and then add them up to get a total volume of the grapefruit. This here is just our data. You can see each of the grapefruits had the same width, and then they had different radii, which resulted in different volumes. The volume we decided to keep high in the equation so it would be more accurate. And then for our total volume, we had 198.33 pi centimeters cubed.
Alright, our next calc concept was volume by rotation, and we chose a pineapple as a medium for this concept. I think we were both partial to this because we got to get pineapple at the end. So to begin this process, we first removed the crown of the pineapple, which is basically like this leafy part here. Therefore, that will not be included in our total volume. Next, we cut the pineapple into quarters and chose 1 quarter to trace onto graph paper. Now, by tracing onto graph paper, we were able to plot points, and we chose 12 points, and the coordinates are shown here. Utilizing those points in the stats function in Nikita's TI, we were able to look for a regression equation that best fit these points, and we found the quartic equation to have the highest accuracy of approximately 98%. And then that provided us with the function p of x, and so this is the quartic equation, and then we were able to plug that into this formula, so p of x squared and then integrated from 0 to 15, and we multiplied that by pi to get a total volume of 1,310.758 centimeters cubed.
And we did 0 to 15 since the pineapple, our point started at 0 and ended at 15 centimeters.
Alright, so we know taking the volume of a few fruits isn't totally interesting, so we decided to spice things up by launching a watermelon off Nikita's chicken coop. And by launching this watermelon, we were able to find the area under the curve as well as the arc length. And then here's our video.
Yeah, it's kind of more like a toss than a launch, but it's the right idea. You know, it had a really nice splat at the end too.
Yeah,
It was
it's
very
I
satisfying.
just had to get an image of that.
So all of our data came from this one video, so we had to figure out how the heck are we going to turn this video into data points that we can enter in our calculator. So I chose to do this by taking screenshots at every second or so of the video, and then using Photoshop, I took the slices of these photos and merged them together to create this photo here. And continuing to use Photoshop, I measured each of the lines. And so it's kind of confusing because I'm getting inches of a photograph on my computer, and we wanted the realistic data under the curve. So I had to create some kind of scale. For the scale of ours, I used that this line is 10 feet on my playset. So 10 feet happen to equal exactly 3 inches in Photoshop. So I used that scale, and measuring them all in inches is the top graph. And then to convert them to feet, all I had to do was multiply by 10 and divide by 3.
Alright, then utilizing these points, you're able to use the stats function again like we did earlier for the volume by rotation, and you're able to find the regression equation, which also happened to be a quartic, and this one had an accuracy of like 99.99%, so worked out pretty well for us, and that provided us with this function, which you were then able to take the derivative of just to give you an idea, this is a general formula for finding the arc length. So after we took the derivative, we were able to plug that into the general formula. Now, we wanted to find the arc length from 0 to 15.625 feet. So for the means of this, A will be 0 and B will be 15.625. And then our next slide shows our calculations. And so as you can see, we just plug in the derivative for here. And that gave us a total arc length of 25.3335 feet.
So the next step was to find the area underneath the curve of the path of the watermelon, and there are several ways to calculate area under the curve. I chose to do it using the trapezoidal theorem. So this here is staying with the measuring in feet, so we get the realistic measurements of the path. And then using that, my approximation of 0 to 15.625 W of x was approximately 163.87 square feet. And so this is just an approximation, so I wanted to know, well, how close to accurate is this? So to do that, I used my calculator to do integrate W of x from 0 to 15.625. It was 167.6389. So it was approximately 4 square feet off, so I thought that was a fairly accurate estimation. And so why did we choose to do fruit? Well, we both really like fruit, first of all, and then summer's almost coming. So it kind of has a summery feel.
Yeah, we also wanted to do something that was a little bit different because we looked on all the old videos shown and there were none of just like plain simple things like fruit. We did find a bananas and potatoes one, but we figured we were safe. So we just wanted to do something unusual and show that calculus really can be applied to anything, and it was definitely like the fundamental part of our presentation. Alright, so throughout our research we found this video that I just think you guys should see. Can you turn up the volume? It was just, I don't know who created it, but.
Yeah, but you can tell this man is a calculus expert. These are just some of our, we didn't have very many sources because all of our project was hands-on.